Hi and welcome to video notes 8.3, and today we're going to be talking about multiplication properties of exponents, specifically ones with like bases today, and what a like base actually is. If that sounds familiar, kind of like terms, it's similar, but with exponents versus adding and subtracting like terms like variables of x and x squared. So it is similar in that regard. We're going to go ahead and start off and take a look at what that property is, and then we're going to go ahead and remember what our properties that we learned in the previous video, and then we're going to do a couple quick examples. All right, so this property is the property of multiplying like bases. A being the base is the large number, correct? And if they're the same number or variable, whatever it happens to be, then you take whatever their exponents are, and you combine that base into one, and you add the bases. Whatever the two exponents happen to be, you add them together. That's what it ends up becoming. Okay, so that's what we're going to explore today. But don't forget, we have a couple rules that we're going to use today as well. One being a negative exponent, and remember that a negative exponent takes whatever position it is in the numerator or the denominator, and it switches it. So this a happens to be in the numerator, which I like to draw an arrow down saying, hey, move it to the denominator. And if there's nothing there to replace it, a 1 holds its place as the numerator. And don't forget, any base raised to the 0, anything, it could be a smiley face, right? Raised to the 0 power, it's going to be equal to 1. Again, rules that we covered in a previous video. So here's a short remembering of how these work. If you have like bases, you're going to go ahead and add exponents when they're being multiplied. If there's a negative, you're going to move the base, whatever position it's in, you're going to switch it. And then always, any base raised to a 0 power will become 1. So let's use those properties, specifically combining like bases and adding exponents is what we're going to do here. So in these examples, we're going to have exactly a like basis. We're not going to see any unlike bases here. So looking at this one's a number. The base is 11, the exponent is 4. It's being multiplied by another base of 11 with an exponent of 3. Well, what happens? Well, this is mathematically what happens. We combine the bases, and when we combine the bases, we add the exponents. So it ends up being 11, base 11, raised to the 4 plus 3 exponent, which we can all do that in our head, is going to be 11 to the 7th. Now, we could multiply that out, but it really says simplify, and there's no need to, in this particular instance, to multiply that out. So we're going to leave it 11 to the 7th. All right, let's see one with 3 bases. Again, we've got the base of 2 raised to the exponent of 5, or to the 5th power. We've got that multiplied to 2 to the 2nd power, and we've got 2 to the negative 1st power. Now, while there's lots of ways to go, we could move the negative 2 down. Let's go ahead and combine all the bases and see if we get lucky and eliminate the negative, and then we don't have to employ that rule. So if we take this, all the bases that are being multiplied together, being the same, all 2, are going to go to one base of 2. And then we're going to take all the exponents, and we're going to add them together, and adding a negative 1 would really look like subtracting a negative 1. So if we look at this, we've got 5 plus 2 minus 1, which is going to be 6. So this result is going to be 2 to the 6th power. And now notice, we don't have a negative, so we don't have to employ that rule. All right, that's a quick section of notes on that. I'm going to do an example video for this as well, and we'll also see some examples on ones that are a little bit more complicated. All right, we'll see you in a minute.